we have stopped with which topic today? Remember? Huh? Some topic. Some heptane and octane. And the problem solve பண்ணீங்களா? என்ன answer? 72.55 வந்துச்சா? Everyone got the value 72.5. Yes. So coming to the yesterday's one thing. இங்க தான பிரச்சனை வந்தது. This thing endothermic. Actually, yesterday, see, there is your solute molecules. When it is taking your solvent molecules, what happened here? Your bond is formed. So I said you have to take 10 kilojoule and 10 kilojoule. Here, let's suppose 5 kilojoule is the energy release. Hypothetically, this is the thing what I disclosed yesterday. Okay. So let me understand you in this way. It's calcium carbonate. This is a molecule. Okay. So what happens here? It will absorb the heat and it will break the compounds into calcium oxide and carbon dioxide. Correct? So here you can say your enthalpy of formation is endothermic and it will be like plus 3768 on the Maribor. Similar reaction, okay, take it in this way. Sorry, methane with oxygen, CO2 and H2O. Here, what happens in the sense your delta H formation will be like around minus 278 in the Maribor. Okay. See here in calcium carbonate, the bond is getting break. Okay, so bond is getting break in the sense the amount of heat that is getting absorbed and it is getting break. Okay, so that's a positive word. Say for example, if your CO2 is getting break in the sense carbon and oxygen the mari break aagudha appadina inge enna agum appadina the value will break 2768 and the mari. So here I calculate about the net charge. That is fine. At the end here formation of bond is here. Correct? Here, just take this part and it is an element. There is no bond formation. Okay. Here, you can see there is a formation of bond. So that's why you can see least amount of energy is released. Clear with this one? So least amount of energy is released. And here you can see more amount of energy is absorbed. Okay. So net charge, of course, the value will be minus. Why minus? Because there is a bond formation. Clear up? Net charge minus the because of the bond formation is there. But you have to compare in positive deviation. This bond is very, very weak. Intermolecular force of attraction is very, very weak. So that's when energy release is very, very small. But the net will be minus where what happens? Your solute is combining with solvent. Clear? So that's minus value. Clear up? Bond formation is so delta product minus delta reactant is equal to your net charge will be negative because of this bond formation. But you have to compare. Here the energy released is less, but here the energy absorbed is more because here in between solute and solvent more amount of intermolecular force of attraction is there. Clear up? Okay, wow. Yes. So now we are getting into our heptane and octane. Is complete பண்ணிட்டீங்களா? இந்த problem try பண்றீங்களா? See, I actually exercise index questions ellame na பண்ணிட்டு இருக்கேன். I have solving each and everything. Your book bags exercise questions as well as index question. In any of the question is missing in the sense at the completion of class I will take everything. Apart from your exercise and index, you want questions, sir? Or only that much level will be asked in your exam? Huh? Sorry? Questions of assignment is fine. Like I'm asking, like in English publications, there will be more amount of questions will be there. You want to discuss that thing, or in text and exercise questions enough? Huh? Engage publications book we can solve because so far I have solved all your index. Go and see your exercise as well as index questions. I'm solving each and everything. Okay. So try this question. Two liquid A and B have P naught A is to P naught B. After completion of the solution, where which chapter we can move? Next week solving la. Do this one. So for this one, mole fraction of vapor A. So your P total is equal to P naught A. Sorry, XB. So your P naught A is 1, your XA is 1, plus P naught B is 2, and your XP is 2. So which means 1 plus 4, which is 5. Now, this is your P total. Mole fraction, na? PA is equal to of A ketirukanga. So PA is equal to P total into YA. So which means YA is equal to PA by P total. PA in 1 divided by P total 5. So 0.2 is your YA and YB will be 0.8. Simple problem. Huh? Don't want to do any direct conversions. Directly you can take an update. Okay. Everyone got this thing? Okay. So now we are getting into a new topic, that is azeotrophs. Yes. Shall we move on? Isn't it special? Now, can move to a new topic is azeotrophs. Okay. So have you heard this word simple distillation Directly, if it is not possible in the sense, we will take the surface area. Yeah, because surface area is very small. So in that part, we will be safe. Okay. So suppose if the mixture so I say two mixtures can be separated. There is no possibility of separation. So now read this definition. When at a specific composition, the solute and solvent start behaving as a single molecule, which means if they both behave as a single molecule, in the sense they'll become stable. Okay, wow. And a molecule of same type, as they both start boiling at the same temperature. In simple distillation or in fractional distillation, the boiling will be having a difference 100 degree, 40 degree. In fractional distillation, 100 degree, 92 degree. That difference will be there. But here, both the mixture will be boiling at the same temperature. So if both are boiling at the same temperature, it is possible to separate? No, you can't separate it. Okay. So it cannot be separated even with fractional distillation. This type of mixture is known as azeotropic mixtures, and this process is known as azeotropy. And do remember another one more thing. While this two mixtures is just achieving the condition, at that time, the mole fraction of your solute and solvent in the solution will be always equal to the mole fraction of your solute and solvent in the vapor phase. This is also one more condition it follows, which means in solutions also what happened? You can understand this line now. Okay. What do you understand? Vapor phase in the sense, let's suppose your solute is there, your solvent is there. Just take your solvent can be volatile. Your solute can be non-volatile. Definitely the volatile component is clear. So at that time what happens in solution and vapor phase, both the mole fractions should be equal. So if both of them equal means you can't separate. Both of them combined means the attraction will be more. They'll be behaving like a single molecule. They'll be stable. And both of them boil at a constant temperature means you can't even distillate. Clear? Yes. So shall we move to the next one? Minimum boil. Oh, okay, okay. Sorry, sir. Next, idhula andi indha prachana varadu. This definitions in your book it's எழுதிக்கோங்க புக்லயும் இருக்கு. Okay. Finished. Next one is minimum boiling azeotropy. See, minimum boiling azeotropy is your solute, solvent is there, your solvent, solvent is there, your solute and solute is boiling in high boiling. It's having high boiling. Your solvent, solvent is having high boiling. They both are boiling in that. Solute and solvent is having low boiling. Which means connected with the positive and negative. So this thing, see, your solute and your solvent. Oh. Exactly. Solute and solvent will be there. So how it is positive deviation? Why are you saying it's positive? More way, exactly. And also due to the intermolecular repulsion. Correct. So the intermolecular force of attraction is very, very less. What is certain positive deviation? Vapor will be more vapors will be there, more vapor pressure you can see. So if there is less intermolecular attraction in the sense, less boiling is enough. Okay, to separate the mixture. Correct. So here, this minimum boiling, no? Okay. So in this minimum boiling azeotropy, just less boiling point is enough to break it. Okay. So first one, break it in the sense it's not possible. Azeotropy in the sense we can't break the mixture. Just to make the mixtures part of each other. Okay. Anyways, we will be doing the boiling point. So here in the sense, here less boiling will be there. for this solute high boiling point, and this solvent also high boiling point will be there. Okay, so now we can move to the graphical representation of this minimum boiling point. So this is your Raoult's law. According to the Raoult's law, again I'm just simply writing it. 1 xb is equal to 0. Another one more example is, let's suppose if I'm taking water. Water will be having an temperature of 373.50 15 Kelvin, and your ethanol will be having around 373. Okay, 351. So exactly in your book it will be 351.5. So if I'm combining the solute and solvent in the sense, my net, that is on total, the boiling point will be 350, which means it is lesser than your water. Again, it is lesser than your ethanol. So now I'm just drawing here for ethanol and water. So XC2H5OH, here if it is 100% and your water is 0%. Okay, so here XC2H5OH is 0% and your water will be 100%. So here it will be like 80, 60, 40, 20. And here 20, 40, 60, 80. These kinds of compositions will be there. So this is the Raoult's law curve. Okay. So now, according to this Raoult's law, the curve is done. According to the minimum heliotrope, what happens? Your ethanol will be having the P0 A and your water will be having the P0 B. So it will start boiling and the boiling point will be reduced at this point, and again your water will start its boiling point and your boiling point will be reduced here. This is the fixed composition or the specific composition where this mixtures cannot be getting separated. Clear? Bye, ma'am, later. All school uniform clean first, your late snacks are. So don't ask for break. Okay. Already taken a break. Yesterday? So today break. Or what about this 20 minutes break? You understand this curve? What you understand? What you understood from this curve? Okay. Here there is your ethanol. Ethanol's boiling point is 351.5 Kelvin, and your water is having 373.15 Kelvin. This is your specific composition. See, do note the point. Specific composition, when they are both are combining together, it will be a fixed composition. Specific composition where you can't distillate it, you can't separate the mixtures. Okay, so here the specific composition here. Initially, what happens in your book, the graph will be very much better than what I have drawn. So here, what happens when it's not getting boiled, as I said, the boiling point will be getting. So it will be reduced and it will be coming into this fixed composition. Again, your water also will be getting boiled, and what happens is this composition. This is the fixed composition where you can't distillate the mixtures. Okay, so that is known as heliotrope. So here you can't even further distillate, you can't even further separate the mixtures. So here your boiling point will be 350. So which means 373, 351. It is lower than your pure solute and solvent. 350 and less boiling point because less intermolecular force of attraction, more repulsion. Clear with this one? Yes. So now shall we move for the negative? Sir, so again, maximum boiling point. So that minimum boiling heliotrope is obeying a positive deviation. So here, in negative deviation, what happens? Your solute and solvent will be having more intermolecular force of attraction, less intermolecular force of attraction. I'm saying about pure solute, pure solvent. Less intermolecular attraction. Very good. So your solute and solvent will be having more more intermolecular force of attraction. So more intermolecular force of attraction in the sense to break the bond, your boiling point will be higher. So this is maximum boiling point. Clear with this one? See, unga book la para so much para, so much para, so much para. Understand the concept and read the theory, you can understand the thing. So here, solute and solvent. So here the vapors produced is very, very less and less vapor pressure will be existing. Clear? So now we can go for the graphical representation. Okay. So it will be like the similar one. So here I have taken, in according to your book, it's HNO3 and H2O. Boiling point is 359. 359, and here for water it's 373 Kelvin. XHNO3 and XH2O. So here it's 100%, here it's 0%. XH2O 100%, XHNO3 0%. Okay. So it will be in increasing order. So here, as I said, the boiling point will be getting increasing. So it will be keep on increasing, and it will come to this fixed position. And here again, this will keep on boiling, and it will come to this. This is the specific composition. And here you can't further distillate or separate your mixtures. Okay. Clear with this one? Shall we move to the next topic, qualitative properties? Temperature here, it will be like 378 approximately. It will be having higher boiling. Okay. Everything is in your book. So further, we are moving into the last topic, that is qualitative properties. Kolama, see. So far, we are just speaking about the solute. These qualitative properties will be mostly focused on the number of moles of solute that is present in the solution. Clear? Of course, the solvent is also there, but the qualitative properties majorly will concentrate on the number of moles of solute that is present in the solution. It doesn't care about how the solute is present, the size of the solute, quality, whatever it may be. Only just the number of moles of solute. Qualitative properties only speaks about number of moles of solute. Okay. So there is 4 major qualitative properties. First one is, all the 4 things. If I completed all the 4 things, the chapter is completed. But each and everything having, for each and every topic, there is 10 problems is there. So that only you will be getting a better kind of understanding about this chapter. So we can move to our first one, that is relative lowering of vapor pressure. This is the qualitative properties. Those properties which depend upon the number of particles or number of moles of solute. Irrespective of its nature, in the sense, even the size of the solute is small or big or repulsive or attractive, whatever it may be. Number of moles of solute that is present in the solution. Okay. Copy this 4 model. Now play irukom. Guys, following, scroll kila panna. Meleya. Finish job. See, following week you are having physics test. Maths and physics. Chemistry eduvingla. Huh? Adukku adutha week. So when you are going to write alcohols, phenols, ethers? July enda. Okay, it's a consensus only. Okay, I'll ask with everyone. Don't turn like that. Okay. எரிமலை எப்படி பொறுக்குறோம் எப்படி திரும்புறீங்க? Like, you know, test is secondary, mark is secondary. How you like when you're exposing to n number of questions, you will get that kind of confidence. That's what the thing. School படிக்கிறதா இங்கேயும் படிப்பீங்க. There is no kind of difference, right? So, that's your wish. Next week, I'm going to start a fourth chapter. Okay. So, if you keep on piling up, I don't know. You have to say what is the fourth chapter. We have completed 2 organic, so we can complete 2 physical. Electrochemistry definitely will be starting. They'll start in your school, so we can complete 2. Huh? They are going to start solutions. After solutions, okay. இன்னுமா எழுதுறீங்க? இதெல்லாம் book what? See, this is all the book itself. Like underline in the book. If you just keep on writing, it's when we will solve the problem. Huh? Okay. Relative lowering of vapor pressure. First, qualitative properties. See, very, very important. All the qualitative properties, all qualitative properties are very, very important, especially the numericals. Okay, to understand each other. Already I have said this relative lowering of vapor pressure in your round saw. Okay. Now I'm just brushing up. See, initially, take a chamber. So in this chamber, when I'm dropping, this is a chamber. Okay. So in this chamber, I'm dropping a pure solvent. Only solvent is present in this chamber. Okay. So if there is only solvent, what are the papers? More number of papers will be there. Clear up. More number of papers will be there. And its vapor pressure also more. Only pure solvent is present here. P not A. This is present here. Now, if I'm adding a non-volatile solute, what happened? Vapor pressure will be decreasing. The vapors will be decreasing. That is your relative lowering of vapor pressure. Okay. So when solvent is individually present, its vapor pressure will be high. But when the solvent is present with your non-volatile solute, at that time what happens? Your surface area is decreasing. Because see, of course the solute is non-volatile. Clear? The solute is non-volatile. But what happens if you go and make interaction? So what happens? It won't that much easily release the vapors. So that's why there is a decreasing in your vapor pressure. That is relative lowering of vapor. Huh? Actually, I don't know about your 12th syllabus or 12th chapter or anything else. I don't know about your exam itself. Okay. You may now earning the first batch. Okay. I have taken for IIT JEE. Concept is similar. They will ask an exam. You have to cover from one end of the book to another end of the book, right? So they will ask in exam. I'm the one taking question paper. How can I know? Okay, so first one, see here, I think there is only pure solvent is present there. So in your solution, now we can keep, see for here afterwards, I'll keep it as P1 and P2. P1 is your solvent, P2 is your solute. We can keep it this way. That is what, that is how in your book textbook also there. Okay. So P1 is equal to P1 not X1. Do you remember this thing? What is this thing? What is P1? What is P1? This one is solvent. So what is P1? Vapor pressure of your solvent present in the solution. Okay. What is this one? Vapor pressure of your solvent when it is present in the pure form. P not connect pure form. What is this one? It's mole fraction. Mole fraction of your solvent. Clear with this one? Now we can connect with the relative. P1 is this is actually vapor pressure of your solvent in solution. How much amount of solvent will be there? That is, this thing is in pure form. can connect with C. Delta P. Your relative lowering of vapor pressure is denoted by this delta P. So delta P is equal to P1 naught minus P1. So what is P1 naught? Exactly. Vapor pressure of your pure solvent minus your vapor pressure of the solvent present in the solution. So in this P1 we can substitute the above equation. So that is delta P is equal to P1 naught minus, for this P1 we can substitute P1 naught into X1. Clear with this, Sipa? So now see the P1 is present as a common term in both the things. So remove that thing. Del P is equal to P1 naught 1 minus X1. Clear with this one now? 1 minus X1. So now we already know mole fraction of the solute and solvent is always equal to 1. So X1 plus X2 is equal to 1 means X1 is equal to 1 minus X2. Clear? So X2 is equal to 1 minus X1. So in place of this 1 minus X1, we can write X2. We can write X2. So now X2 is equal to delta P divided by P01. Okay. So now what is delta P value? P01 minus P1. Clear? Clear? Now I am substituting here. X2 is equal to P01 minus P1 divided by P01. Clear? So this X2 is nothing but mole fraction of your solute divided by mole fraction of the solute plus mole fraction of your solvent. Solution. Okay. So now you can write this as N2 divided by N1, which is equal to P1 naught. Wait. N1 plus N2. Okay. But so we will not incorporate that thing. N2 divided by N1 is equal to P1 naught minus P1 divided by P1 naught. This N2 is nothing but number of moles. That is given mass divided by molar mass. So we can substitute that thing here. Can you understand? Number mole fraction. Mole fraction is equal to number of moles. So here, what happens? So in this N1, this is nothing but a number of moles. Number of moles is equal to given mass divided by molar mass. So now I'm substituting nothing here. So which means here we can take this as number of moles. N2 is equal to given mass of the solute divided molar mass of the solute by given mass of the solvent divided by molar mass of the solvent, which is equal to P1 naught minus P1 divided by P1 naught. So what happens? So this is your final formula. P1 naught minus P1 divided by P1 naught is equal to W2 by M W2 divided by W1. Okay. So W2 divided by கீழ என்ன வரும் இது மேல போச்சுனா into M1 divided by M2 W1. Clear? See, this is very important. In your book, இததான் வந்து கொடுத்திருப்பாங்க. Take and see in your book. This is a derivation. Clear with this derivation? Now we can solve the problems. This is a formula. Relative lowering of vapor pressure formula. Got this one? Now we can go for the problems. Okay. So now we can go for the problems. Everyone got this derivation? Okay. Now, do the problem. Okay. See. P1 now. P1 very P1 okay. And non-volatile, non-electrolyte solute. So solute given mass 0.5 39 gram of benzene. Okay. So which means 39 is nothing but your P1. Yeah, exactly. P1. P1. How much P1? In grams they have given. So this is actually given mass of your benzene. See, solute. So this is your solvent. Here, benzene is your solvent. So this is nothing but the given mass of the solvent. So molar mass you have to find. See, this takes its molar mass in your 12 into 670 molar mass. And where the rest of the solution becomes. So here they have been given your P1. Clear? I'll write this thing. See, this is pure benzene. So, which means your P01 is 0.850 bar. Solvent in solutions. Wait, one thing. In solution, can you discriminate the solvent and solution? Solute or solvent? We have to take it only this way. Correct. There is nothing called? No, P2. This is the formula. We won't take P2. Okay, so just calculate this one. You will be having, when you're solving more number of problems, you will get this one. So now, P0, then P1 is equal to 0.845 bar. So this is nothing but our solute's given mass. So given mass is equal to W2. Solve given mass is W2 0.5. We don't know the molar mass. Okay. For benzene, given mass is 39. So its molar mass is 78 sure. 78. We have all the things. So now you have to do the calculation and find your molar mass of your solute. Every calculation is in front of you. So from the formula, P1 naught minus P1 divided by P1 naught is equal to given mass divided given mass of the solute into molar mass of the solvent into given mass. So now P01 850 minus 845 divided by 0.850. So W2 is 0.5 divided by M2. We have to find it into molar mass of benzene is 78 divided by 39. Do the calculation fast. Done now. What's the answer? I'll do here. Everyone got 1.7. And do remember, where the rest of the solution and equal to, right? Just two parameters. This P1 is solution given means P1. Pure means P1 not. Okay, there is no other formula. P1 not, this is the formula. Shall we go to the next one? Another one more small thing is there. It's a very simple thing. See, this solution, apart from this solution, we solve this derivation. Correct? So in this derivation, we neglected the sense in solution. Okay, your solute will be very this. Let's suppose if your solute is having more kind of percentage. See here, your relation will be less than 0.1. Okay, now read this question. Read this question. What is the mass of the non-ferritative media? Must be added 100 grams of water. Honestly, man, silent la put it. So basic but just please put in silent. Okay, already 100 grams of water to reduce the vapor pressure by 40%. That means the solute is reducing 30% of vapor pressure of the solvent. So which means its composition is high. So there you can neglect. See, your mass is totally 100 grams. Okay, solvent. What is the volatile one? So what happened? Your vapor pressure will become more vapor pressure. So if we have in your solute. So in the previous one, solute we have added is very less. So we have neglected. Like suppose your scale is 30% if you are adding to reduce the vapor pressure means definitely your solute is more in numbers, so you can't neglect it. You can't neglect it. So what happened there? Here arises another one more formula. Shall we see that formula? Shall we see the derivation? Directly I can put the formula. Derivation and finally the formula will come and we can solve one problem. If you are facing any competitive exams, if you are facing any competitive exams, it will be useful. And XII, there is one problem they have disclosed. Okay, so see the derivation. What is the last one's formula? Relative lowering of vapor pressure formula will be P1 naught minus P1 divided by P1 naught is equal to given mass of the solute divided by given molar mass of the solvent. Molar mass of the solvent divided. This is what the thing. Okay. So now we can write this as X2. Okay. So P1 naught minus P divided by. This is what the thing. So now how we can take this thing in the sense this P1 is nothing but what is P1? The vapor pressure of the solvent in the solution. So now here we are going to make it. So which means we can put this P1 as P1 naught minus PS divided by P1 naught, and this we can write this X2 as number of moles of the solute divided by number of moles of the solvent plus number of moles of the solute without neglecting the N2. Here you shouldn't neglect the N2. Clear? So now we can reverse numerator denominator mathalam. Okay, we can reverse this thing. P1 naught divided by P1 naught minus PS is equal to N1 plus N2 divided by N2. Clear? So now P1 naught divided by P1 naught minus PS is equal to N1 divided by N2 plus N2 divided by N2. So cancel, 1 will be obtained. P1 naught minus P1 naught is equal to, okay, this is plus 1. So when this plus 1 comes here, it will become minus 1. Okay, minus 1 is equal to N1 divided by N2. P1 naught minus, just bring it to this numerator, P1 naught minus PS divided by P1 naught minus PS is equal to N1 by N. So which means this and this will cancel, minus minus plus. So this minus minus will become plus. PS divided by P1 naught minus PS is equal to N1 by N2. So now again reverse the thing. It will become P1 naught minus PS divided by PS is equal to N1 by N2. This is what the formula for your dilute solution where N2 is not getting neglected. Clear? So which means your solute is having more amount of grams in your solvent. Okay, in the solution also. Clear with this one? This is not there in your book, but if you want, you can copy it in the exam point of view or competitive point of view, anywhere. Clear? So now with this formula, you can ask me like why we need to interchange the numerator denominator. If you're not interchanging, means the value of PS will be in minus. So that only we have interchanged. Clear? So now use this formula. You have to solve the problem. The formula puruchada. Why we are using this formula puruchada? That formula we have been using. It is a very direct solution where your N2 is getting neglected. Most of the problems you will be using only that formula. Okay. Sorry, N2 by N1. Yes, N2 by N1. Sorry. Okay. Now we can solve a problem. This is your problem. Now solve it. Try to solve it. Just solve one problem. That's enough. What is your P01? 100. Very good. P01 is 100. So which means your PS will be 30%. 100 minus 30, 70. Clear up. So now what about the rest of the one? See, here I have stopped with N2 by N1. So you have to write it in given mass divided by molar mass. Okay. So you have to like, this will be like P01 minus PS divided by PS is equal to N2 na given mass divided by molar mass. This is the formula, final form. Okay. So here, what is the given mass? 100. Now calculate it for urea. We have to find the mass of the, given mass. So what is the molar mass? Molar mass of urea is NH2CO NH2. So nitrogen is 14, 14, 28 plus hydrogen 4, 2, 2, 4, 28, 4, 12, 16. So which means 24, 32, 32 plus 12, 44, 44 plus 16, 0, balance 1, 4, 5, 6, 66. Correct? And now here, 60. 60, correct. So now here, there is water, okay? So water given mass is 100, molar mass is 18. Yeah. So now, just drop everything in this equation, calculate and see. So P1 naught is 100 minus PS is 70 divided by 100 into given mass we have to calculate. Molar mass is 60 into 1800. We have done this thing. Check this one. You got 4.2. So 30 divided by 100. So here it comes means 60 into 100 into 18 is equal to W2. 30 to 60. Hey, see, this is 70, right? PS. Exactly, 142.8. Here it is 70. So 70 into 18. Now we will be getting the answer. 142.8. Got this one now? Huh? Just try to know it. This is not important in your exam point of view. That formula is important. Okay, this is not important. Shall we move to the next one? Everyone clear with this one? Okay. Why we are using this formula? When a solvent is present in maximum quantity, we can't negate that thing. So we are using this formula and we are applying the answer. Clear? Molality. Do with the molality. What about molar? What is the answer of molality? 4R. Molality is equal to given mass. So given mass, what we have? 142.8. 142.8 divided by molar mass was 60 into 100. See, 1000 divided by for water they have given 100. 100. So 142.8 divided by 6, 23.8 moles per kilogram. That is your molality. Okay. So now we are getting into the next one. Actually, I have still volatile. Of course, volatile. Slow evaporation is there. It is a volatile. If you just go through the Google means they'll say non-volatile. But what is a volatile? Slowly the evaporation will take place. Wait. Non-volatile urea. This is a non-volatile solvent of Tamil Nadu. So if it's a non-volatile solvent, that means the process will not take place. Which means one should be volatile, another should be non-volatile. So the one which is volatile will be exceeding the vapor pressure in everything. We are adding everything with the vapor pressure formula only, right? So one thing should be volatile and another thing. What they will not give us non-volatile. Clear? Okay. Next one, elevation boiling point. So you will have the problems. Okay. So far you understood. Okay. So now I'll say an important thing. Okay. Okay. You are writing your thing. Immediately your bikes. So yes.
Ma'am, your voice is too low.
So I'm calling engine heat direction. They are saying the engine got hot. Okay. So you have to add water. You know, water add. You have to add water. So which means you will be adding a water or do you know one thing to cool the engine part to keep the thing, they will be adding a water. But that is not a water, it is coolant. Do you know coolant? Okay, why the coolant is added instead of water? To cool when I add a water. Very good, evaporated easily. But I'm adding coolant. What is there in coolant? Non-volatile. Non-volatile. What is non-volatile? Coolant is nothing but a heavy water. What is heavy water? Means more amount of electrolytes. Clear? So, to the solvent. Okay. So you are just not dropping your water. The coolant is nothing but a heavy water. There you are not just water. Dropping the water. Water, which inside the water there is more amount of non-volatile solutions there. So which means water is having a boiling point of 100 degrees Celsius. If you are adding the coolant in the system, the boiling point will be more because you will be having more amount of electrolytes. So it will increase the boiling point. That is what elevation and boiling point. See now, when pure solvent is added, water is added with a non-volatile solution, like you are adding your electrolytes and everything. So the boiling point of the solution will increase.
some electrolytes to it. So what happens? Still the boiling point will be getting increased up. So that's why we are adding this kind of electrolytes. That is nothing but a non-volatile solute. Okay. So to a pure solvent, you are adding a non-volatile solute. The boiling point of the solution increases. Okay. So this is known as elevation boiling point. Increasing in boiling point. Clear with this one now? What is elevation boiling point then? Clear up. Your solvent, water, you are adding all your electrolytes. So what happens? Your boiling point is getting increased. That is what the process is happening in your coolant also, which is you are dropping into a car or bike or everything to keep the engine cool, because it will be having more amount of boiling point. So that is known as heavy water. More amount of ions will be there. Clear up. So now we can see the formula for this thing. So more amount of ions will be there. Okay, heavy water, electrolytes also will be there. Clear. So this is your formula of elevation boiling point. That is delta TB is equal to TB minus TB naught. So this delta TB is nothing but your elevation boiling point. And what is TB in the sense? Boiling point of your solution. And this TB naught is nothing but boiling point of your pure solvent. Clear? Not pure. Always do remember that thing. Okay. So this is your pure solvent and this is your solution. Now, in your book, okay, see, del TB is directly proportional to molality. Why I am including molality in the sense? See this topic. Qualitative properties and the determination of molar mass. Molar mass of the solute. Clear? Solvent is also their solute. So that's why this delta TB is directly proportional to your molality. Molality. So now we know the formula of molality. Yes, another one more thing is delta TB is equal to Kb into M. What is this Kb in the sense? It is your molar elevation constant. It is also known as ebullioscopic constant. This everything will be in your book. Ebullioscopic constant. Okay. So now we can write the formula of molality here. Del TB is equal to Kb into formula for molality is equal to given mass of the solute divided by molar mass of the solute into 1000 divided by that is present in 1 kilogram of your solvent. Given mass of your solute divided by molar mass of your solute. Wait, I'll write it here. Del TB is equal to Kb into given mass of a solute, molar mass of a solute into 1000. Right? W1. Yes, W1. Okay, now they have incorporating ideal gas constant here. So in terms of ideal gas constant, this formula will be Kb is equal to, actually it's not important, but still take a note. M1 into this R is nothing but your ideal gas constant. Okay, R into TB square divided by here boiling is taking place up. So which means vaporization is happening up. So delta vaporization enthalpy into 1000. So this is according to your ideal gas constant. Again, according to latent heat of vaporization. What is latent heat of vaporization? IV. Okay, you have studied in your 9th standard or 10th standard. What is latent heat? What is latent heat? Energy supplied to change. Why there is no change in temperature?
Okay, you're right, but partially. Okay, let's suppose my beaker is there. I'm dropping ice. According to the latent heat of vaporization, how they will write in the sense, this all the thing, okay, will become IV. So now KB is equal to R into TB square divided by IV into 1000. So just get the information about this thing, but this is important formula. You are going to apply in your problems. This is important. IV is latent heat of vaporization. And this R, this is according to that, R is nothing but your ideal gas constant, latent heat. But this is what they will give the KB value. They will give the KB value and it will be Kelvin kilogram per mole. No, they'll be giving in the question itself. Don't worry about that thing. Okay, they'll be disclose everything in the question itself. No. This is wait, M1 divided by is equal to 1 by IV. Okay. So I can interconvert delta vaporization enthalpy by F1 is equal to I. Clear with this one till this. Now we can move for the next one. Depression and freezing point. After that, we can make some problems and we can just another two more qualitative properties. Osmotic pressure. Depression. Huh? Only one osmotic pressure. Huh? That is depression and freezing point. Huge osmotic pressure. And for abnormal frequency, degree of dissociation will be increased. But here there is 10 to 15 problems there. So yeah. Next Saturday. Okay, so go on the 1 minute. See, the following Saturday is 2 you are going to write your test, and another Saturday, 3 Saturdays constant. 8 Saturdays. So any one of the Saturday write alcohol phenol ether. 2, 9, 16. So 23 எழுதுறீங்களா? July 23. Four exams. Four exams, how many chapters there? Which one? So before that you have to write
in oral chapter, write 2 tests. Another one more test in halogens and halogens and 2 tests in alcohols, phenols and ethers. This will be there. எப்ப எழுதுறீங்க? First week means 2. This week, the following Saturday, I'll hear everyone's opinion. First, 2 on the alcohol phenol ether. That is 2, man. This week and next. This week illa. This week illa. பதட்டப்படாதீங்க. Okay, don't get tense. This week illa. Or else you can write in any one of the chemistry hall. இப்போ இந்த மாதிரி 5 to 6 எழுதுறீங்களா? Writing following week எழுதுறீங்களா? Following week Thursday. Next week தான்ப்பா. Next week only next week தான். See, the coming following Saturday. When is your school test? Okay, fine. So before that, write 2 tests on your hand. You have written halogens and halogens. Okay. We have to say everyone's opinion towards this thing. Both combined in the sense. Okay, 2 la எழுதுறீங்களா? Okay, for following Friday, are you okay to write the test? Because following Friday, I'll complete the 3rd chapter. 4th chapter, you'll just say solutions. Solutions முடிச்சிடுவேன். 4th chapter அதுக்கு அடுத்து கூட electrochemistry is quite simple only compared to solutions. So following Friday, are you okay to write alcohol phenol ether? Thursday maths. Following Friday, alcohols, phenols, ethers. Okay. Okay, at least write before halogens you have completed. At least write 1 test on alcohols, phenols, and ethers before your school conducting the test. Okay, so when is the day? You just give the date. That's it. Online test, how I know I put your online test. Okay, I know how you will write the online test. So either 2, 9 or 16, any of one of these days, please write alcohols, phenols, and ethers. Coming following Friday, following Friday 30. 31. But hey, dude, school test na sunna. And 2 you go after completion of the day. 2 evening only you're going to write the test. From morning you have 24 hours, right? Why? Write this week, day after tomorrow. You're free, right? Hey, no more funding. Come to the topic. Just do whatever you want. No test. See, following Friday, alcohol, phenols, ethers test. That's it. Even for 14, 15. No, I'm trying to connect you to test ID. See, don't worry about your concentrate. Following Thursday. Okay, ma. Following Thursday. Okay, ma. Depends upon the class. Okay, ma. What about your first day? I don't know about your maths test. Here, your institute test. No, man. July 14th or 15th is okay. At least 2 tests in 1 chapter. Now only I test 1 set. See, I am going to decide a day or days. Friday, hey, listen, this Friday, I'll call speed on teacher section. Hey, see, from today, you are having 1 week, 1 whole week. How can you get to study? Okay. Hey, see, my time is going, man. No, I'm going to complete this thing. Go. Following Friday is your test. Please write it, please. See, in the ஊர்லயாவது நான் அதாவது I am the teacher. I am just requesting you. Please write the test. What is this thing? Depression breaking point. This Friday, following Friday, test on alcohol, speed on sneakers. After that, we can decide whether we can combine or we can keep the test. Please, so that definitely you can see a difference in your marks in your school test. Okay. Depression breaking point. So I'll complete this one and we can solve 2 or 3 problems. I will. Not kulfi of man. No, the kulfi that is one in the box. Okay, a man will cover it with a big, huge red cloth. In that he'll be having an iron rod. So that kulfi, okay, that kulfi will be. Okay. So that kulfi. There will be a salty flavor will be there. Kulfi is after the layer. What do you say? What is the Uppu Thanni makes there? What the salt water will do to the ice? Huh? So immediately you're just dropping that kind of solution on the ice. Immediately it will melt, that is your drying solution. Okay, your sodium chloride will be present in that. When you're immediately you're just dropping on the ice block, what happens? This is a solute. When it is react with the solvent, it will easily forms a solution. It will liquefy. Clear? So, now you just read this definition. Now you read the definition. See, when a non-volatile solute, say for example in Kulfi itself, in a discussion. Okay. So now read this definition. Now you will be understanding the difference. When a non-volatile solute is added to solvent, non-volatile solute is your salt. When you are adding to the water, what happens? It forms a solution. Correct? So if it is we are freezing in the sense, in that freezing point, there is water is there. But in between the water molecules, your non-volatile solute will be there. So your freezing point will be still more getting lesser. So your freezing point will be getting less, decreases. Ice is 0 degrees Celsius means if you're adding salt to it, what happens? It becomes -4 or -3 degrees Celsius. So the freezing point of the solution decreases as compared to that of the freezing point of the pure solvent. Now you got this one clear up. So we can see the formula for this one now. Yes. Oh, this is a graph. Okay, you just copy this thing. I'll draw the graph for that one also. Got this one? Okay. So we are adding your non-volatile solute to the solvent to decrease the freezing point. There, you're adding your non-volatile solute to the solvent to increase the boiling point. ரெண்டுமே ஒண்ணுதான். Particles வந்து close ஆகாம freeze na your liquid இருக்கக்கூடிய particles எல்லாம் எல்லாமே come closer together. Okay, correct? So if more amount of solute is there, means more time it will take to melt. Clear? That is what thing. There, if more amount of solute is there, means more time it will take to boil. Clear? Yes. So now we can see the T delta TF is equal to TF minus TF naught. So what is this TF? Freezing point of a solution. This is the freezing point of the pure solvent. Okay. So this is nothing but your depression freezing point. Finally, try the test. Okay. So this TF is freezing point of your solution. This is the freezing point of your pure solvent. So this value is also equal to the, is directly proportional to your molality. So which means delta TF is equal to KF into M. There KB into M. Here KB solvent. Yes. Solvent. Solvent. See, this formula here we have been using KB. KB is nothing but your what is that thing? Molar elevation constant or ebullioscopic constant. So here this is nothing but molar depression constant or cryoscopic constant. So this is cryoscopic constant. Molar freezing constant. Side line. Okay. So now again apply the value of M, molality. So what will be the formula? Del TF is equal to KF into given mass of the solute divided by molar mass. Given mass of solute divided by molar mass into 1000 by W. Here. So again, அதே மாதிரி இதுலயும் நம்ம என்ன பண்றோம்னா ideal gas constant. So அதேதான் KF is equal to M1 into your ideal gas constant TF square divided by delta their vaporization because boiling. Here it's freezing. So fusion. So delta fusion enthalpy into 1000. Okay. So here, if you want, you can also include the latent heat of vaporization. Now here there will be no latent heat of vaporization not be there. Okay. Yes. So now I'll draw the graph. Just listen this graph, very, very important. First one is for your elevation in boiling point. See, for elevation in boiling point,
This is your graph. Okay. So here will be your temperature, and here will be your vapor pressure. Okay. So equal to 1 atmosphere. So elevation and boiling point. Why I have included this 1 atmosphere means, what is boiling point? Liquid's vapor pressure should be equal to the atmospheric pressure. Clear up? Boiling point enna liquid or vapor pressure it should be equal to the STP. That is, it will be equal to the atmospheric pressure. Yeah, of course. Okay. So here I have included this to 1 atmosphere. Now, what are the components we are taking? Solvent and solution. So when it is present as a solvent, so inge irukum solvent. So inge ennaagum appadiye increase agum. Boiling point, what happens? It will be getting increasing. So your solvent, okay, keep on increasing. So here your temperature will be there. So this is your solution. So in solution, you can see in solution, in the elevation and boiling point, you will be having your non-volatile solute. Clear up? Up it will be having still more boiling point. So see, the graph will be going in this way, having more temperature. So this is your solution. So here your solvent. So solvent in the sense T, pure solvent. When it is solution means delta TP. So this is your TB. Sorry, this is TB. Delta varappa. Okay, see, note this point. In relative lowering of vapor pressure, in solution, the vapor pressure will be reducing out. Can you understand this graph? Solvent initially. Can you understand this graph? Solvent in terms of elevation boiling point, solvent will be having this much amount of temperature. Again, in solution, there will be more amount of non-volatile solute. So you can see increase in temperature. Now, compare the solvent and solution in terms of relative lowering of vapor pressure. There I said, when you compare to solvent in solution, your vapor pressure will be lesser. Below the solvent, your solution is there. Clear with this graph? Yes. Now we can go for the next one, that is depression and freezing point graph, Kolama. See here. Depression and freezing point. Again, similar one. Your temperature, vapor pressure. So now at one point it will come, it will be getting reduced. Okay, so here your solution will, your solvent will come to this point. Why I have marked this point in the sense, this is the point where your solid will be getting converted into liquid. Okay, and again completely it will be getting freezed. Clear up? Okay, so now in solution what happens? Solution again it will come and join here. So this is a point and this is a point. So you can see there is a decrease in temperature for solvent and solution. So here if it is 0 means here it will be -1. So it will be getting decreased. So if this for solution, it will be TF, and for pure solvent it will be T0F. So this comprises of your delta TF. Okay. This is what your graphical representation of your depression and freezing point. Everything is there in your book itself, similar way. Clear? So this is the point where the equilibrium will be there. Number of solid particles and number of liquid particles will be equal. This is the point where the equilibrium, and again if it is freezing completely, your solid will be converted. So here also you can see solution also similar. Clear with this depression freezing? Latent heat of vaporization, in latent heat of vaporization, at one point what happens? Your solid will be getting converted into liquid. So at that point, not all your solid will be completely converted into liquid.
similar thing. Okay? Yes.
So now problem solve பண்றீங்களா? ஒரு problem பண்றீங்களா? 629 I'll do one problem. See, I have included more amount of problems. Next class la panna, no issues. Calculate the first one. They have given is elevation boiling point. Take the formula of what is the elevation boiling point formula? Delta TB is equal to your KB. That is nothing but your ebullioscopic constant KB into molality, given mass of your solute divided molar mass of your solute into 1000 divided by W1. So now, what is your KB? They have already disclosed 0.52 Kelvin kilogram per mole. What is your given mass of the solute? Huh? Given mass of your solute in is it 12?
What is this one? Molar mass we need to find out. So here 1000 divided by 52. Yes, do it. Come on.
Huh?
0.48.
I have given everything. 0.8 KB வந்து 0.52 into 12 divided by we don't know M2 into 1000 divided by 52 gram of water. Yes, simple calculation. So bring the M2 here. 0.52 into 12 into 1000 divided by 0.40 into 52. அவ்வளவுதான். 0.52 into 12 into correct 300. Okay, now in our next problem homework வச்சுக்கோங்க. But do remember, see, no issues. But in this problem,
This is in degree Celsius. This is in Kelvin. Correct. So you need to convert your degree Celsius into Kelvin, which is nothing but plus 273. Correct. And now we can calculate this problem.
homework வச்சுக்கோங்க. Or else இங்க பண்றதா இருந்தாலும் okay. என்ன என்ன வேணா பண்ணிக்கோங்க, டைம் முடிஞ்சது. இங்க பண்ணி ஆன்சர் சொல்றா இருந்தாலும் ஓகே.
What? Exactly. That is
Can you scroll up?
which means convert it into Kelvin. Wait. Okay. Here they have given the boiling point solution. They have given your del TB. Del TB is equal to your TB minus T naught B, right?
You're clear with that one?
So here they have given your
delta H delta TB is equal to your TB minus this is for the formula. So now here we know it's 100.1 degrees Celsius. அப்படியா? எங்க சொல்லுங்க? clear correctா? சொல்லுங்க.
see what they have given. Calculate the molar mass of the substance. It is 1 gram salt in 100 gram of water. Here the boiling point of solution. 100.1 boiling point of the solution.
Exactly. TB is your 100.1 degrees Celsius.
What is your T naught B? What would maximum 100 degree? What would maximum boiling point in 100 degrees Celsius?
So which means 100 degrees Celsius. So it will be like 0.1 degrees Celsius. இதை நீங்க convert பண்ணீங்கன்னா 0.1 Kelvin தான் வரும்.
See, here you plus பண்ணுங்க 373.1 Kelvin minus 373 Kelvin 0.1 Kelvin. So now we can do the problem. Clear up. See, elevation boiling point directly can do this here. But look at the problem. Here the boiling point of the solution na kuduga. Boiling point of the solution, vapor pressure of the solution, everything will be on P1, P like that. So now you can carry over. You follow everything. Correct? Panunga.
So 0.1,
52, very good.
so 0.1 into 0.52, okay va, kb, given mass என்ன கொடுத்திருக்காங்க 1 gram, 1 gram divided by, we don't know the molar mass, into 1000 divided by 100. இன்னொரு ப்ராப்ளம் ட்ரை பண்றீங்களா? இல்ல கிளம்பு. m2 is equal to 0.5 இது ஹோம்வொர்க்கா பண்ணிட்டு வரீங்களா? Hey, there is 1 week time, man. Do this problem as a homework. Oh, இது சிங்கப்பூர் புறப்பட்டு ரேஞ்சுக்கு போறீங்க.
Copy this problem and leave. Friday, add the calls P not P plus test for sure. Seriously, I want to postpone the test. Enna? I'll discuss with sir. But Friday test irukku. வேணாம்னா okay.
Hey, right.
For the benefit of your sake, money I'm saying. மற்ற சப்ஜெக்ட்டும் படிங்க, கெமிஸ்ட்ரியும் படிங்க. Why?
காப்பி பண்ணியாச்சா? See, I have more problems. எல்லாமே போட்டு வந்தீங்கன்னா இன்னும் நல்லா இருக்கும். ஒரு 8 ப்ராப்ளம் இருக்கு. போட்டு வரீங்களா? Okay, fine. We can do it here. It's one topic and we can discuss more amount of problems. See, எல்லா ப்ராப்ளம் மிக்ஸ் பண்ணும்போது அப்ப வரும் கன்ஃபியூஷன். Henry.
Question. அதே யாரும் பார்க்கல. Find molar mass of solute.
Repeat எழுதுங்க. Find molar mass.
Directly we can find out.
இல்ல directly இல்ல.
Hey, man, here there is benzene is like volatile. For non-volatile, they're asking.
Okay, va? முடிச்சிட்டேன். எல்லாம் எங்க போய் அழுகுறாங்க.
Ma'am, can you scroll up?
அப்படியா?
Hey, following week test. என்ன? Okay, go. நான் போன்.
அவங்க மிரட்டுறாங்க. டெஸ்ட் பண்ண மாட்டாங்க.
பாரு.
Yeah, I said to I told to discuss a question paper today, right? For Harvard scoring here. You want Understand? At the end,